All right, I'll try to make it work. Okay, so section 12.4, we are continuing with the statistics. Today I'm going to talk about the normal distribution and what that is. You probably have heard something about a bell curve. If you've read any kind of articles where statistics are being quoted, they usually mention something, oh, on the bell curve, this person fell here, this person fell here, whatever that means. The normal distribution, that's what we call something that's also called the bell curve. It's probably the most widely used of all of the probability models, okay? So data can be distributed in many different ways. It can be spread out more on the left. So basically, like, this is the most people, but then to the left, we have other data points that kind of take up the left side of the graph. We could have more data on the right. So like most people answered whatever this was. Most people happened right here, but then we had little stragglers to the right. Over here, most people answered here. That was like the average of the answers, but then we had people answering to the left of that. Or it can be very random and it's just like a random bar graph or histogram that you guys have been making. We're moving on to be looking at something that's called the bell curve. There are many cases where the data tends to be around a central value, all right, with no bias left or right. So that means most of the population or most of the scores happen to be in the middle. This is what we call the normal distribution. And usually in nature, in populations, in anything that revolves around a big amount of data, whenever it revolves around real life, it's usually the bell curve model. Most people fall within the middle and there's little outliers to the left and to the right. The bell curve is called the normal distribution. So I need you guys to be able to recognize that that word means exactly the same thing. And this, it used to be yellow, but now the PDF is dark gray. So the dark gray, the histogram, shows some data that follows it closely, but not perfectly. So like if we were doing the histograms, even the ones you're doing on the quiz, and then we were to draw a line, a lot of them would probably fall to follow that bell curve, all right? So the bell curve comes from having a histogram and then you connect it to make a nice line. Some variables typically modeled by normal distribution, and this is, like I said, it involves real life, so it could be height, weight, IQ, memory, reading ability. So it measures things that happen to real people or animals or objects, all right, that we use in real life that have human kind of a factor to it. The normal distribution is completely described by two population parameters. So that means there are two things that are involved in the bell curve, and those are the mean and the standard deviation. So in the previous section, you guys were calculating the standard deviation. I made you learn how to do that on your calculator, but you're like, well, it's just this random number. What do we use it for? Why do we even calculate it? Today, you're going to find out. There are two Greek letters. One looks like this. It looks like a U, but it's really pronounced mu. Like, I don't know, it stands for the mean. And the standard deviation, it's the Greek letter sigma. So if you see any worksheets or videos or anything else that I'm going to be posting, we usually say the mean, the average, but you might see this letter there. So don't be confused. It's just a symbol, just like pi. Pi is a symbol and we all know, and you're familiar with it. It doesn't confuse you because you've seen it a lot of times. And sigma, it's like this O with the little line at the top. All right, so that's that one. The mean of the normal distribution is its center. So the average is exactly in the middle, and the standard deviation measures the spread of the distribution about the mean. So the standard deviation tells me, is everything spread out really, really wide, and it's going to be a very a very wide bell curve, or is everything narrow and it's going to be a very steep looking bell curve? All right, so some things that closely follow a normal distribution: heights of people, size of things produced by machines, error in measurements, blood pressure, and usually tests. Like, we kind of know, unless I give you a test that is way too easy, like if I gave you a test that involves adding numbers less than 10, you probably would all get A's. But if it's something within the normal lesson, it's kind of expected that some people, you know, we always get A's, some people get B's, C's, so it's kind of spread out in a normal curve as well. We say that the data is normally distributed because, and we know this middle part, exactly in the center of it, is the average. And what's also happening is that this number will also be the median and be the mode. And that makes sense. Like, the most people answer that question, that's the average. That's also the mode, because it happened the most frequently. And if you find the median, that's going to be the number in the middle. All right. So that number in the middle is those three things. And the bell curve is also symmetric. So basically it means 50% of it is to the left, and then the other 50% is exactly to the right. So it's a mirror image on one side to the other. Okay. Although there are many normal distributions, there's a well-known property that we will have to remember. It's called the 68, 95, 99.7 rule. It's also known as the 3 sigma rule, 3 standard deviations rule, or some people call it empirical rule. We're gonna, most likely, you're gonna hear me say, hey, use the 68, 95, 99.7. So if you had to memorize anything from this page, it's the 68, 95, 99.7 rule. Okay, I'll stop for a second because I did go through this very quickly. Are there any questions? All right, moving on. So what does that mean, the 68, 95, and 99%? For every single bell curve that we're going to do, we're going to use this distribution. Approximately 68% of the data points lie within 1 standard deviation of the average, of the mean, of the center. 95% of the data lie within 2 standard deviations of the average, and 99.7% of the data lie within 3 standard deviations. So standard deviation is this number that we were calculating, and I'm going to show you how it works. So here's what it means. Let's say we have an average of some sort, and it falls exactly in the middle of this. All right. The 68% means that 68% of the data, let's say we had 100 people, 68 people would happen to be in this yellow portion of the graph. They would answer, they would score, their heights, their weight would be within that. So it's almost like almost 3/4 of the people. 95% is going to be falling within all of this. So I'm going to color this in because it's the yellow and the pink, the way they have it. All of this would be 95%. So 95% whenever they answer something and it follows the bell curve, their answer will be within 2 standard deviations from the mean, within that portion. Finally, the 99.7 is, let me use green. In addition to everything, it's going to be this green little portion right there. So it's all of this that I'm shading green, okay? It's going to be 99.7 within that graph. That's where they're going to fall on that graph. Now, what about that 0.03%? That is, if I was to zoom in on that graph for you, it's right here. So it's past the 3 standard deviation mark, and it's very, very tiny. This is actually 0.015 of the whole total, all right, because the total is 100%. And same thing on the other side. It's covered up by this little thing, but it's outside. It's so tiny that it usually has very little effect on your calculations or anything you're going to do. All right. So that's what the 68, 95, 99.7 rule says. Okay. So that's basically like the background of it. That's the, and what I would like to be able to do with you guys is see if you can actually redraw that. So this is where you would actually open up Notability, go to page 3 of this packet, and maybe, you know, at some point follow along with me, because this will be something you need to know. In the standard bell curve, this is the mean. All right, so you need to be able to label that. Then we have these numbers. It's +1 and -1. That means 1 to the right and 1 to the left. That means it's negative. So this would be 1 standard deviation to the left, and to the right, it's 1 standard deviation to the right. And this portion right here is the 68% of the data. So 68% of the data fall in here. Within 1 standard deviation of the mean, that's what that means. The next 2 lines, so like right here, and oops, that's a bad one. And right here, this will be the 95%. So 95% of the data falls within 2 standard deviations. So you would count 1, 2 standard deviations to the right and 2 standard deviations to the left. Finally, for the third one, we'll have this guy right here, and I was going to write it up above because it's a bigger number. 99.7%, it's from here to here. So this is -3 and this is 3. So you would count 1, 2, 3 standard deviations, 1, 2, 3 standard deviations to the left. Any questions? All right, so over here at some point I'm gonna have you guys do this on your own, where you like sketch the normal curve and then you represent what the percentages are, 95 and 99.7%, okay? So you have to remember that for the 68%, that's within 1 standard deviation, 95 is within 2 standard deviations, and 99.7 is within 3 standard deviations. Okay, this we'll do that next time also, because this is the same thing. I'm just going to have you redraw it until you're very comfortable and familiar with it. Okay. Let me see. So let's go to this example, because I feel like it's all, you know, a good idea to see a problem actually, like, what does this mean? The 1, the 2, the 3. So I'll just do this example and I think we'll be done. So an IQ test is used to assess human intelligence. The average score is 100. Standard deviation is 15. So the average score is 100. That goes in the middle. This is the average, so it's 100. Now, the standard deviations, it's kind of like your increments for your scale to the right and to the left. So in order to find the next line, we're going to add 15, and this will be 115. The next one will be plus another 15, So this would be 130. This would be plus 15 again, so it's 145. And what this means is that this is one standard deviation, because the standard deviation, if we were to calculate it and do that calculator thing to find standard deviation, and the answer would come out, oh, it's 15. So that would mean that's the increment on the bell curve, 15, another 15, and another 15. To the left, we would subtract. Minus 15 would be 85, minus another 15, that would be 70, and minus another 15, that would be 55. So the range for this bell curve is from 55 all the way up to 145. So that means in this range of data, the way they calculated it, the lowest IQ score was 55 and the highest one, they got 145. Of course, there might be some outliers that are either below or above, but those would not fall into the bell curve. So question 1A, find the IQ that is 2 standard deviations below the mean. Below means to the left. So the one that's below, and I would count, okay, I'm going 2 to the left. So this is 70. And you just pick it up from the bell curve, 70. Find the IQ that is 3 standard deviations above the mean. So that means to the right. So it's 3, so I count 1, 2, 3. So it's going to be right here. And this is 145. I'm going to stop because z-scores, and for the next one, I'm going to explain that later because that's, another little formula that I have to explain. Well, z-scores, it just represents like how many points did you count. Z-score of 130, 130 is 2, positive 2, because it's 2 standard deviations. And score of 55 would be negative 3, because it's 1, 2, 3. It's negative 3 or 3 to the left of the mean, 3 lines. That's basically what it is. All right, I'm gonna stop right here. See if you have any questions.